Today we're going to be talking about graphing and an introduction to it. So firstly, we're going to be talking about what graphs are. Then we're going to be talking about parts of a linear equation that are necessary to make a graph. And we're going to be talking about how to interpret graphs. And then lastly, we're going to be giving some examples to help clarify. So what are graphs? Well, basically, they are a 2D plane that uses x and y values. As you can see here, there are the y values on this y-axis, as well as x values on the x-axis. And essentially, you would just input x and y values to use a graph. For example, one way is through coordinates, where it is in this format of x comma y. An example would be 2 comma 5. So we have numbers, but how can you show that visually? Well, this coordinate is essentially just a set of conditions where it says that it can be any point on the graph that has an x value of 2, which is represented by this line. However, it also has to be a point that has a y value of 5, which is represented by this line. Therefore, we can see that where the lines intersect is going to be the coordinate, where it has an x value of 2 and a y value of 5. So how do you use linear equations on a graph? So linear equations are also just a set of coordinates rather than just one point. We have multiple points that form a line. And these lines are the linear equations. So we have a standard form, ax plus by plus c equals 0, where x and y are the variables and a, b, and c are real numbers. So firstly, roots and x-intercepts. Well, it's basically just the part of the line that touches the x-axis, meaning if this was the line that we're dealing with, then the part that touches the x-axis would be here. And really, for any line, this entire x-axis are potential x-intercepts. And what can we see that is consistent with all of them? Well, the y-intercept for any of these points are 0. Therefore, if we set the y value of any linear equation to 0, we would be able to find x equals a number, and that would be our x-intercept. Additionally, we can also find the y-intercept. Much like the x-intercept, it is the part of the line that touches the y-axis rather than the x-axis. And additionally, you can see that any part on this axis are potential y-intercepts. And the similarity between all of them is, instead this time, we have the x value is always 0. So if we don't set the y to 0, but this time we set the x to 0, we can find y equals blank, and that would become our y-intercept. Lastly, we have a slope, and it is a rate of change between 2 points. Essentially, I like to call it rise over run to help make it stick in my head. So what does this mean? We would try to find 2 points, any 2 points would work, and we would try to find the rise of those 2 points divided or over the run or the movement from left to right of those 2 points. So just an example, here you can see that we have 2 points, which is determined by y2 minus y1 over x2 minus x1. These can be any 2 points, which basically just show how far up using the y values it is, which is the rise, divided by the difference between the x values, which is the run. For an example, we can have 2y minus 3x equals 6. As you can see, this is in our normal standard form, where the 6 is on this side, but you can just move it over here to get negative 6. So firstly, how do you find the x-intercept? Well, it is when the point's y-coordinate is 0. So as I said before, you can set y equals 0. Therefore, you get negative 3x equals 6. And then in this time, it's easier if you leave the 6 on the other side, when you can just easily get x equals negative 2. Therefore, when y coordinate or the y value is 0, you get negative 2. So the x-intercept is negative 2, 0. For the y-intercept, it's the same process where you set x is 0, and this time you get y equals 3. So therefore, the x value is 0 and the y value is 3. And lastly, we're going to be talking about the slope of this example. And as I said before, it's going to be the rate of change between 2 points. However, how do you find these 2 points when you're just given this equation? Firstly, because you're just finding any 2 points, you can just choose a random number for x or y. As you sub into the equation, let's say, for example, if I choose where on the line is x going to equal 4, I'm going to get y equals 9. So therefore, we can get our first point as 4, 9. And then for the second point, you can just repeat this process to get a second point, which I got was 2, 6, just to make it easy. And as we use the equation y2 minus y1 over x2 minus x1, we can just use really any set of coordinates as y2 and x2 or y1 and x1. And then you just make sure to put them in order, where let's say if you want 9 in this case to be y2, you have to make sure 4 is x2. And then you just get 9 minus 6 divided by 4 minus 2, and then you can find a slope of 3 divided by 2. And that just concludes our lesson on graphs.